All right. Back now to exponential and logarithm equations. For these problems, find all the solutions to the given equation. If there is no solution to the equation, clearly explain why. So here we begin. We'll take 7 from both sides, rather take 12 from both sides, and then divide both sides by -4. So we'll have 5/4. Natural logs of both sides, ln of 5/4 is 7 add 3x. So then take 7 and divide by 3. And we'll get the calculator for this. So x is about -2.258. 2590. And the next one, we take 10 from both sides, divide both sides by -3. So we have -9 over -3, which is 3. So what appears to be e to the z squared, take 2z equals 3. And we'll just move that over. By the quadratic formula, but then, is that valid? I guess it appears so. We'll solve this third one and then check. Move 2t to the other side, so we have -2t, and then divide by -t, so we have just plain old 2. Or rather, think a little bit. There's one solution. No, that should be positive. Ln 2 plus 1 over 6. Zero 0.282. 282. All right, so we'll check. All right, that's accurate for dp for that. And that's correct for that. And that's correct too. All right, excellent. Fourth problem. We'll take natural logs of both sides, right? Could do. So here's what we obtain there. So it would appear that one, 0.9494. and the negative. Yeah, I think that's fine. Just x is not allowed to be negative a quarter. That's all. Just oh. I knew there would be something like this. We think that if we do have x be negative a quarter, then in the original we could get 0 equals 0. But no, like, it doesn't apply to this here. Fifth problem, find all the solutions to this. If there are no solutions, explain why. Just move it to the other side and wait, how do you do this again? Well, why didn't you view it like this? We've got 2e to the 3y at 8 equal to 11e to the 5 take 10y. And we can divide both sides by 2. And then we could take natural logs of both sides, but hold on, no, we can't because of this guy here, right? But 11 over 2 is just e to some power, isn't it? So we'll say this much. Oh, no. Right, okay. Whoops. Let's move it over. So I make it to be 0.0902. I'll need to be corrected if that's the case. Oh my goodness. What? Of course. Okay. 6-1. There's no answer to that. just do them one at a time here. Okay, got it. You can add logarithms together. So express one as lunny, lunavi. Sorry, and then factors become multiplied. I believe that's correct. And then take exponentials of both sides. And then y take 3ey. I think that's the answer. Right. It's very important for me to realize you cannot have very important for me to realize that. I wonder if this will be another trick. Common logs, but they're being added together, so we can just multiply the arguments. Exponentials of both sides. Oh, no, beg your pardon. 10 to the both sides. So 10 to the 2 is 100, so but Good. All right. This is one among many reasons why I admire these notes. Clearly, okay, next. So I think both of those are valid. I think so. All right. And finding all solutions to this. Well, we took 11, so 5 equals 17 to the t minus 2. Log base 17. Good. I don't need to use the change of base formula on this calculator, so that's fine. $18. Good. And now, compound interest. These 14 problems to solve. 13 and 14 to solve. The principle. Three and 2/3, which is 11/3. And now monthly. Hold on, excuse me. Okay, so 3 and 2/3 of a year, which is 11/3 for t, 11/3 for t, and then we must multiply it by 44. 11 times 44 is 454. 454/3. Continuous, of course, this doesn't work because you'd have to have infinities floating around. All right, so miscalculation was obviously done up there. So it must be corrected. Now 11/3 is not multiplied by 44. 11 rather is multiplied by 12. like that. So those are the answers. That's correct. That's correct. That's correct. Mm-hmm. $10,000 is a goal, but that'll be divided by 5,000 eventually, so a half. All right, so that's absurd. Oh no, that should be 2. Of course. $5.86. Right, that's correct. Now we'll be looking at exponential growth and decay. Q equals Q0 e to the kt. $1,600 over 250, 160 over 25, 6.4. Divide through. So lunate. And that'll be divided by that quantity there. If you divide by a fraction, that's the same thing as multiplying by its reciprocal. 5 on there and 6.4 there. That many days. And now we use the exponential decay equation. like that. Okay, so drop the negative sign. Don't know where that was introduced. Here. Got it this time. Yeah, that's good. Yep. Although I expressed it as a decimal. Yes. That's right. All right. So now for the next problems, which are common graphs. Without using a graphing calculator, sketch the graph of each of the following. And there are many to do, so it's good to begin. Now they ask for a sketch. So what I'm going to do is highlight the important features, explicitly name them when I can, and then give a rough sketch of how it looks. For example, this first one is a linear function. So you better get its positive or negative slope correct. And also you better find its x and y-axis intercepts. So for the y-intercept, it's straightforward, just substitute x equals 0. And for the x-intercept, set it equal to 0 and solve for x. So 4/3 of x equals 2. So x equals 2 times 3/4, which is 1.5, or 3/2. And we might remark that m is 4/3. So when you graph it, 4/3, think, what would that look like? Just a little bit steeper than the y equals x line, which has that sort of perfect 45-degree slope. So that point there, 3/2, 0. And that point there, 0, -2. That's the first one. For the next one, we have the absolute value function. The absolute value function. This is usually a V shape, and in this case it is a V shape. What is the effect of subtracting 3 from the argument x? That will shift the entire graph 3 units to the right. Translate it 3 units to the right. And that means that the x-intercept is no longer the origin, but rather 3 itself. And as for the y-intercept, well, that would also be 3. So let's sketch it now. Now, here's a mistake I continuously make. Calling this the y-intercept, but there's no such y. It's the intercept of that axis, the f of x axis, because there is no y-axis, unless you make one. Okay, so should look like that. Just like that. Then we'll do the third one, and then we'll check so far. We'll check for each 3. Yeah, that sounds pretty good. Okay, so this will look like the sine of x graph, except translated up by 6 units. So, what can I say about this? Well, the vertical axis intercept will be 6 instead of 0. And the x-intercept, the x-axis intercepts or roots or zeros will be all that we are accustomed to. So who's that? Will it? Oh no, it won't. It'll have none. It'll have none. We might say the range. What is the range? 5 to 7. And otherwise it's just fine. So let me think about this. G of x. And what we need is this. Let's see. That'll be 2, and therefore 6 below. So -1, isn't that right? So actually, it should look like this. If I'm imagining that's 2, 4, 6, and 7. Yeah. Like that. Oh. So I'm better drawing that in that direction. All right, time to check. Yep, I agree. That's good as well. And yes. Okay, f of x is ln of x take 5. Oh my, okay, so I better get a move on. Well now, f of x is ln of x take 5. Well, what's the usual ln of x graph like? Something like that. And so translated downwards by 5 units. So what can I say? Vertical axis has no intercepts. The x-axis usually it would pass through 1, 0, because the natural logarithm of 1 is 0. Wait, have I completely lost my mind? So it would be e to the 5. I don't know what I'm thinking. Listen. That's not how it works. That's strange. Well, I guess it would be that then. I'm not sure why that broke me for such a period of time. But I guess I encountered something which stopped my thoughts. Like a Medusa sentence or something. And why is this stopping my thoughts? That's really strange. Yeah. I know that that's huge. But anyway. Right, better try this one. Cosine of x plus pi over 2. So that will be the cosine graph, but shift it to the left by pi over 2. Oh, right. I was going to do like an analysis and everything, right? Okay, well, doing that just makes it look like the negative of sine. So and again, I make this y variable out of nowhere. I've got to get out of that habit. I know it doesn't really matter, but I don't want to do that. Like, I am going to go really overboard with this. Like, super mega ultra fussy with this. Do you know why? Because this is what graphs are like. I don't know exactly what I mean by that, but it's just... All right, let's see. This is in vertex form. And what is the advantage to this again? Well, and if I expand it, I'll get... There was some way to just very quickly and rapidly get the points that you desire from this. Anyway, we can just think of it as the x squared graph, but translated to the right by 3 units and upwards by 4 units. Doesn't that make sense? And therefore, the y-intercept will be 13. Wait, is that right? Oh, man. No, that is right. Let's also describe it a little bit. Flexing my vocab. Opening upwards. Yes, it should be 13. X-intercepts or roots, none. Line of symmetry. 6. What do you mean 6? Well, oh, right, I get it. That's a hidden joke. X equals 6. And finally, the vertex. Let's get the vertex. i.e. the minimum. Okay, well, I've messed this up, haven't I? I think so. 6 minus 3 is 3, and you square it and you get 9. And you add 4 to that and you get 13. What? Okay. Just one problem. How can you have a vertex that's at the same height as the y-intercept or vertical axis intercept? Square it out, you get 9, you have to add 4, and you get 13. Right? It's driving me. What is going on here? Wow. Better just sketch it. I mean, this can't be right. Let's see. You know what? I'm going to figure this out. I mean, this is obviously just a tiny arithmetic error or something. Or I'm just doing a blunder. But it kind of... It's like an itch. And I just need to know what on earth is going on. So, I'm totally sure it crosses the vertical axis at 13. And I've found it. It's supposed to be 3. Goodness me. Right, okay. And now... So we relearn what this form is even for. The vertex form. Look. 3 and 4. That's how you get the vertex from the vertex form. I get it. All right, so label the axes. And the vertex itself. And let's proceed. W of x is an exponential graph translated 2 units to the left and 3 units downwards. Okay, so I have some intercepts to figure out. Okay. I'm insanely slow today, but I don't care. Slow is better than 0. Slow is better than 0. Negative 0.901. Right. Whoa, hold on a second. Minus sign. There. I did it. And again, I have invented y out of nowhere. Even though I promised myself I wouldn't do that. WX. Call that WX. Call that X. And also, yeah. Yep. All right. Vertex form. Oh no. Look at this. Y is the dependent variable. Oh no, he's not going to do this stupid parabola opening to the right business, is he? If he is, never mind. 3. None. Doesn't intersect anywhere. And I'm just going to graph it. One to the left, No, 1 to the right, actually, and 2 units up. Notice the vertex form. This is how we get that minimal point. And there's 3. And that's good enough for me. I knew he would do that. Well, y doesn't have to mean that, and technically this is correct. And you made up x out of nowhere, so see you later. You can't use all these variables and then just expect me to be that way. But anyhow, now we have r of x, which is the negative of the square root function. Function in quotes. There. And if you want a point on it, let's say 4, negative 2. Just a typical point on the curve. This, well, what about this? The square root of the negative of x. So it would just open up towards the left, right? Now, did I label those? I did. Okay, good. It's becoming more automatic now. There. As for a typical point, let's say, no, let's say negative 4, 2. All right, we'll check 9 and 10. Okay, that's valid. That's correct. And that's correct. Here is a quadratic, not in vertex form, but in standard form. Is it factorable? Well, don't think so. No, I don't think it is. We'll do b squared minus 4ac, the discriminant, to check. So we get 9 minus something way above. So no, it's not. It's not factorable, so it has no roots. No, beg your pardon. It's not factorable, and therefore it has no clean roots. But look, the discriminant is 9 minus 32. which is negative 23, which is negative. So it has no roots at all. It's floating above the x-axis. The y-intercept is 4. None. But we do need its minimum. So we get the line of symmetry. Three over 2. Can't just say 3 over 2. X equals 3 over 2. And then input. 3 over 2 squared is 9 over 4. So we get 18 over 4. So 4.5. 4.5 take 9 over 2 is the same thing as 4.5 take 18 over 4. Wait, what? Oh no. What? Square 3 over 2. Alright, 9 over 4. Double it. 18 over 4. 9 over 2. 9 over 2 take 3 times 3 over 2 is 9 over 2 take 9 over 2, which is 0, so 4. Oh no. It's this nonsense again. Do you know what it is? I keep forgetting to double the A. 3/4. Now really try. Vertex. 3/4 squared is 9/16. So 18/16. So 9/8. 9 over 8 take 9 over 4 is the same as 9 over 8 take 18 over 8. 9 over 8 take 18 over 8 is negative 9 over 8. 4 take 9 over 8 is 3 and 7 over 8. 3 and 7 over 8 is 31 over 8. Anyway, that will be okay for me. Okay. Now, here we have a parabola. And this time he is doing it in terms of y, so I'll recognize and honor that. And it's opening up towards the left. So, it's like writing backwards or something. It's a stretch on me. So here's the x-axis intercept, 3. The y-axis intercept, the roots of it, I guess, we get by solving this. Is it factorable? B squared minus 4ac. So 64 minus 4 times 3. So 16 times 3, which is 48. 64 take 48. 16, which is 4. So factorable. So factorable, and so we try. This is not gonna work. All right. 2 then. And then to build 8 out of that. So I think like I want to say this, but I know this isn't right. So did I get this wrong? Is it factorable or not? B squared is 64. Then you have to minus 4 times minus 4 times 3. 16 times 3, which is... Oh no, you have to add it on. You have to add it on. And 64 plus 48 is 112, which is not square. Sorry. Near miss. 112 is 2 to the 4 times 7. So 4 root 7. How about that? That's my discriminant. So we did QF. Like that. Okay, so 1 plus or minus a half root 7. And that's all right, isn't it? That will be fine. But you need the vertex. It's just in the middle. It's 1. And then input 1. So you get minus 4 plus 8 plus 3. So 1, 7. 1, 7, I think. Root 7. So it'll be just a little bit below. Anyway, I'm kind of done with this one. As long as they're in the right quadrants, I'm okay. And we check. Oh, I didn't say that was 3. And I really should. All right. So, for the 13th one, we are presented with a circle to graph, whose center is at -1, 5, and whose radius is 3. And that's fine enough for me. Not figuring all that out. Not right now. Yeah, that's right. Center is -1, 5, and the radius is 3. Now this, well, this is, well, I don't know what it is. It's something in disguise. So what I'm going to do is the x squared and -4x are right next to each other. So I'm going to say x take 2 squared. That captures that. But then I've created a 4 out of nowhere, so I have to take that away. Same here. I'm going to do y take 3 all squared and take away that 9. And then we have this. So that'll bring 100 to the right-hand side. And so it's a circle with a center 2, 3 and radius 10. So it's massive. Freehand circle time. Something like there-ish. There it is. With a bit of work, those intercepts can be figured out, but they haven't asked us to do that right now. Indeed, I agree. Now this 15th one, That is an ellipse. It's an ellipse. And it's an ellipse with a center of -2, 0. But how to handle this 25 business? View it as if it's being divided by 1/25, which is a square of 1/5. So what does this mean? Is it taller than it is wide or wider than it is tall? So here's how I think about it. I think it's wide. It's a wide ellipse, right? How much detail are we expected to know about this? Oh, man, it's tall. It's tall. It's tall. It's tall. And how to think about that? Well, the denominator of the x coordinate is going to determine the x, isn't it? All right, that makes sense. I understand now. I understand. Now, 16. Problem 16. This is another ellipse whose center is 0,6 and which is tall. Did I get that right? Yes. All right, but I didn't graph it, did I? Because I didn't graph this one, and I've been forgetting to do that. Okay, I'll make up for that now. That's minus h over k. X minus h all squared over a squared plus y minus b, y minus k all squared over b squared equals 1. I remember it. I remember it. I remember it. K plus or minus AB, right? So it'll be 6 plus or minus 3. 6 plus or minus 3, I remember. But we can also think through it logically, not just using memory. Yes. 17. 17. This is a hyperbola, and it's opening up towards the right and the left. But how is it opening up? Its center is the origin. But you don't know your conic sections well enough yet. And so these numbers currently mean nothing, unfortunately. Really unfortunate. But so try to figure it out. Try to figure it out. Put in 0 for x. No, put in 0 for y. So x squared over 36 equals 1, so x squared equals 36, so x is equal to plus or minus 6. Like that. But tell me, what happens when we put in x equals 0? Well, then we get negative y squared over 49 equals 1. So negative y squared equals 49. But in this class, no complex numbers. So minus 6. 6. The origin. Hyperbola. And yeah, that's right. But what about the asymptotes? You know? B over A, B over A, B over A, plus or minus B over A, plus or minus B over A. You know what would be perfect? Just completely having complete control over the conics. When you have it in standard form, just knowing absolutely every single thing about that conic on the graph. Every point of interest, everything. But I don't have it yet. But I'm building up to it. And this is another ellipse. No, hyperbola. And this time it's opening up and down. And can you say anything else about it? It has a center of -2, -4, right? Okay. I need more room. So here-ish. And, you know, my knowledge is so lacking about the hyperbola graph that I don't even know if these 2 points, the 2 vertices, are which quadrant they're in. And that is a shame. Figure it out, but I want that to be immediate knowledge. Knowledge that I don't have to fish and fumble around for, you know? So, let's just think anyhow. All right. We'll put a mark here or something. Because this is not enough detail. It's just locating a center. Maybe I could do the asymptotes. The 2 vertices, not enough. But I need to come back to this. But otherwise, I did do it. So what's coming now? Limits. Let's see. A lot of precise and decimally calculations. Okay. Well, I better study. And that's good. Be well.